Hello everyone. This is a short video with respect to system advisory model, SAM. I Most of you will probably use this in your final write-up, so I want to show you a few things. Um, let's say I want to use this to do a project on or a write-up on, let's say, a different part of the world. Okay, so um, although SAM is great, one of the limitations is that it's going to be very US centric. So if you look at, for example, wind, purchase power agreement, like a single owner, right away you'll notice like the options here are just all the files are all for states in the US. You can find if you can find a file for outside of the US, great, you can use it. I assume that most people will not have that available. So what you can do is if you kind of scroll through these, right? Okay. One thing you notice is one of the big factors here is basically this elevation above sea level. And I would say it's not gonna be 100% accurate, but if you find something similar, just use it. So for example, I'm gonna do France. Okay, let's say I'm gonna pick France. Okay, so let me switch the screen here. Let me go for France. I'm gonna try to get a map out here and then see if I can. I go to let's see, I'm gonna go to France, elevation, and then coordinates. Let's see. It's probably not the best here. Let me just go to France, maps.google, and then let's go to France. And let's have a look at the western part of France here. And so longitude code around 46.9, -1. Okay, so take a note of that. And then let's say I want to know the elevation. The elevation of France, the western France. Probably have to just do a regular search here. So the elevation of western France. Elevation, let's get the elevation. It's about mean elevation of 275 meters above sea. So, I'm gonna go back. I'm gonna go back to my SAMS model here. SAMS tool here. And let me see what I can do here. So as we saw earlier, it's about 375. So this actually isn't too bad. So in California. But I think one of the things that I want to do is get the latitude and longitude correctly, or roughly the same. So France was about, I think we said about 47 -1. So you want to get the it's not the longitude, but the latitude correct roughly, right? So it doesn't have, again, if you're off by a little bit, it's okay. It doesn't have to be exact. I would say 46 point around there. That's about northern US. So I would say anything northwestern of US would be a good fit as long as the elevation is okay. So let's see here. I have Northern Oregon, 456. So this is okay. Let's look at this one right here. This one doesn't have this one over off. This is the offshore. If you want to do offshore, you go here. If you want to do onshore, you do Northern Oregon. But this would be good enough. I would say this is fine. Okay. And then from there, you can use some of these built-in resources already. So
You try out different turbines here. I would just look at these capacity number very carefully. And it doesn't have to be exact. You can just get a rough number. So you can pick one like this Enercon 82 meter. This is a big one, 2.3 megawatt capacity. The kilowatt rating here, so you can use those. So what's nice about it is that this gives you an actual financial number, right? So that's why this is very useful. Or you can use the one that we use in class to further for our example in class. The Siemens SWT 3.0 megawatt as well. Okay, so you can use that. And then the wind farm configuration, you can lay this out differently. Remember, the typical is 10 diameter, 10D by 5D. So you can do it that way. You can arrange it differently. You can change the orientation as well. As you can see how you can change the orientation here. You can leave everything default value to it. It's okay because we're looking at really this is a kind of a macroscopic analysis. So you can keep everything default if you wanted to. I would say the top numbers, if you just kind of change these top numbers out so that it matches your analysis, it's fine. And then the other parts like the installation costs, operating costs, you can again keep those the way it is, or you can change them based on your own assumptions as well. whatever you want. And then the revenue, the incentives, this is where you might want to play, you can play around with different incentive ideas. So let's say I just run this without any of that, run simulate. It's running. Okay, so I could change some of the parameters, right? Let's just look at just the output here. Now, again, these summary results are very, very useful. So you can look at the data table that gives you by hour. You can look at the graphs. You can generate a graph if you want. I look at the general, like, if you look at, this gives you the profiles of different parameters. This is the system power generated based on the month. It could also do like, let's say, the probability density function CDF here. So I think the ones we looked at typically are system power generated and the wind speed. So the wind speed here, when you click on it, this means that there was at least, a very small time in the simulation where the wind speed went as high as 21 meters per second. Majority of the wind speed is far below that. And this blue line tells you the average. And this gives you the overall profile. So you're going to get a lot more wind speed at the lower level, but you do get some higher wind speeds later on, or very small numbers, but you do get some very high wind speed once in a while. And this gives you the profile for if you look at system power generated, this is the average again, the blue line, but a lot of times you get this much. This is the most frequent outcome. This has a very long tail here, right? So a lot of times you don't get a lot of wind, or you're not going to get 170,000 kilowatt hour typical day. That's very low probability, but you get something closer to 10,000 kilowatt on a typical day. That's what this tells you. Yeah. So use this as as a resource. I think you can run a lot of different scenarios here. There's heat maps you can look at. I would use it as a resource. You can basically use these graphs as well in your report. Use it as a resource. Okay. And hopefully that kind of helps you out. So again, main thing I want to take away is that you don't have to be 100% accurate on any of these. Like, as in, like, we don't have an exact wind profile for, France or Mexico, Germany. It's okay. Just find something similar. The two numbers that you can just make sure you write down your assumptions in your write up. What the elevation is, where you're looking at approximately, and then the location that you're using as a proxy measure. In our case, I was looking at western part of France. I'm going to use northern Oregon because the elevation is close and the latitude is roughly the same, or it's close to France. Okay. Now, if you're completely out of this, like the U.S. latitude zones from a country, again, it's okay. Just try to get something similar. As long as I can replicate your results in SAM, you're fine. Okay. So hopefully that helps out. Thanks. Bye.